Hello everyone. Today we are going to discuss about the Capstone Project 8, which is regarding bank marketing, bank CSV to use Spark, Hadoop, and Hive in the project. And this is the project summary of 4,521 records and 17 columns that in the initial dataset. And these are the key findings that I have done. Let's discuss more in the uh, inside of the project. And the main problem statement of the project is to find and sell term deposit subscriptions to find for the people who are from different categories of occupations, and with respect to uh, client subscriptions, whether they are subscribing for the term deposit or not, based on the agent calls and based on their income and all. Let us see whether and let us find out more. These are a lot of libraries that I have imported for this project. I've separated each and every one for each and everything for standard libraries and scikit for visualizations, and Spark libraries for ML algorithms, and the Spark as well, and Spark ML classifications as well for logistic regression, random forest, and GPT classifiers. And I also wanted to evaluate using param and cross validator. For that, I also imported those. And this is a common plotting style, and this is Spark initialization with version 4.1.2. I've imported those libraries and loaded my dataset bank CSV, and this is the uh, shape of data frame in both the pandas and Spark as well. This is the first view of dataset, columns and row count. Information regarding how many and what is the data type of each and every column available. Most of them are strings and integers. Only data types available in the dataset, and there are no duplicates in the dataset, so we need not perform any data manipulations or data imputations for this dataset. And coming to missing values, there are no missing values as well. The data is almost clean, so we need not perform any imputations on this. And this is a visualization that there is no impure data in the dataset. And this is what I have mentioned here as well in the insights of my dataset. Coming to the columns of the dataset, each and every column, there are 17 columns and a description of each and everything. And this is the common variable description of my dataset. Checking what are all the unique values of my dataset, I limited to 10 values each because there are multiple balance values, 2353. I didn't want to uh, keep the outcome clumsy, so I limited those to 10 values here. So yeah, based on the top 10 values or the top 10 rows, you will be getting those values only. And coming to my data wrangling, I also created a copy for the other ML operations and Spark operations. And I wanted to see whether I created three more new columns, I guess, for to check whether this subscribed column is in binary section for the last term deposit section, and if the people are previously contacted or not. For that, I wanted to know, and created groups of ages for the people for better analysis purposes. And yeah, based on that, I also showed what are the columns created, and the new columns as well. We got 21 columns. And if there is any negative balance in the account, so I wanted to flag them. I showed a column for that. If there is negative balance, we would be flagging them as 1 and no as 0. And these are all the columns that after the data manipulation has been done. This is what I've mentioned here as well. And coming to chart one, I wanted to describe the age group, the client age group, and most of the people are lying from 30s to 40s, and the mean is 41.2, means like 41 age. And we can almost see that the frequency is around 500 as well. Coming to the second chart is term deposit subscription, whether people are subscribing or not. The data set seems completely biased with 85% no, 88% no, and 11.5% as yes. It is not in a 50-50 range. It is a completely biased data set. So, yeah, and distribution of jobs as well. Coming to the next chart, we can see majorly management and blue collar jobs are leading with the frequency of around 1000 each, 900 to 1000 each. And coming to the next chart is the subscription rate by each job type. Mostly retired people are subscribing for the term deposits, and students as well for their next life as well. I mean, I guess. So the average is here for around like 11% to 12%. Coming to the next chart, that is a call duration versus subscription outcome, whether people who are subscribing or not based on the duration of call. Most we can see that people who are subscribed for 11% are talking around 450 to 500 seconds, and the people who don't subscribe are almost ending the call in the first 1 minute as well. And next is account balance versus subscription outcome. Uh, Here we can see that almost balances are almost similar, around 0 to 2000. Coming to the next chart, that is a subscription by education level, whether people are completing their primary education, secondary education, tertiary education, or people don't have the idea of education. And we can see that most people are near to secondary and tertiary educated people are subscribing for the term policy. And next chart is the categorical visualization of subscription rate by previous campaigning outcome based on the previous outcome, whether they are subscribing for themselves or not. And we can see that people subscription rate is really high. And next chart is the subscription rate for the contact month. If people are contacted in specific month, then what is the subscription rate? Most subscriptions are done in March or October, and we can see very few in May and June. And next chart is the average balance based on the age, whether people are maintaining enough balance and how much balance are they maintaining in their accounts based on the uh, age group. I have shown it as a scatter plot. And next is the variate of subscription rate by number of campaigning contacts, whether people are contacting more, and if people are contacted more, are they feeling uh, to be subscribed or not. Most people are subscribed or after 3 to 4 calls for the each and every subscriber, and decreased again from 5 calls again, because people feel really annoyed after 5 calls for these term insurances things. And coming to the distribution of account balance in euros, most of the people maintain around uh, low balance or a very few balance. This is around each bucket is around 1250. So where we can see that most of the people have no balances, or 1250 range is the max after zero. And the next visualization chart is the pair what is called our chart heat graph, heat map for all the data types. And here comes the correlation map for all the data integer data types, and a pair plot as well for age, balance, duration, and campaign, as we can see. And coming to the hypothesis testing, I wanted to test three hypothesis testings for the average call duration for people who subscribe. The subscription rate may differ, or the average account balance for subscribers. For the first hypothesis, I performed a p-value test based on one-tailed test. And for the result, I've used alpha 0.05, and I found out that the call duration is significantly higher. So alternate hypothesis is true. And for the second hypothesis, I performed chi-square test of independence, and with the same alpha value as well, and I've got reject as well for that, based on the statistical result. So the alternate result is true for that as well. And for the third test, I've used Mann-Whitney U-test for non-parametric skew test for the alpha value 0.5, whether to say subscribers have significantly higher balances or not, and that is rejected as well. And let's pick for the feature processing, I've used the copy data for the data set, and most of the values are similar, and we can see that the IQR values are also ranging for our analysis. Even in the categorical encoding, I've used Spark to show neat and clear data for each and every category. Here we can see that Spark output is here. For the I've shown only 5 results for basic outcome. We can show uh, more as well, but I didn't want to be the outcome to be so clumsy, so I showed only top 5 results for this. And for the feature mapping, I've taken features like log transformation, contact intensity, if the people are previously contacted or not, to show uh, whether about this data. And as you can see, I've showed the data as well in Spark visualizations only. The same visualizations have segregated, each and every section has been segregated for numerical values and binary features, and one hot executive values as well, OHE features, and assembled them and showed these values outcome as well. And this is a SMOT analysis for to show that the data is not leaked, and the train data and test data is split into 80-20 percentage for the outcome, because more than 40 4 uh, around 4,800 rows, so 80% and 20% would be perfect for the training and testing range. So as you can see, the 3,600 rows are for training and 900 rows are for testing. That is a significant one. So as we can see that I've used Spark pipelines to train my data and test the data. In the model implementation as well, I've used, as I've told you, I wanted to use binary classification and vector analysis for my Spark metrics. So I've used those for a ROC AUC, and I wanted to show this is the utility function for all the three functions. And this is my first model, that is logistical regression values. And these are the value output of my logistical regression Spark libraries and Spark regression tables. This is my confusion matrix and ROC curve, as you can see. And this is my cross validation after 6 param combos. The best value is for ROC 0.88. And next is my ML model 2 with random forest classifier. And with my confusion matrix and ROC curve as well. And with and for this random forest classifier, I've used fivefold cross validator with 9 params. It took a bit of time to execute this program because there are around 900 training rows and testing rows. So it took a time. The output came around 8 to 9 minutes, but the best average is for ROC AUC as well. as we can see that the top 15 features. And the third model is XGBoost classifier. For this, I've used 12 param fold, I guess. Let me see, yeah, 12 param combo. This took a lot of time to execute, but I've got ROC AUC as well for leading result. I've also wanted to show all the results comparatively beside each other so that we can see what are the values that are uh, ranging with each other. As you can see here, ROC AUC is leading, and after that accuracy is there. For all the models, we can see that ROC AUC values are high. For all the values, Spark LR and Spark Random Forest, Spark Logistic Regressions, Spark Random Forest, and Spark XGBoost. And from all these three different types, XGBoost will be giving XGBoost has given more accurate result, 0.89. This is the XGBoost after tuning values. And coming to the most important topic of the uh, project, that is the distributed data systems for Hive and Hadoop and Apache Spark, and predictive modeling is what I've showed you earlier in the above three modelings, and real-time analysis and efficient data parallelism is what the objective of this project. And I've connected Hadoop Hive cluster here. As you can see, the Spark Hive has been running, and I wanted to visualize the data. This is the demo data for my data set for Hive table after connection, and for using Hive queries, I've also validated and tested that whether Hive is running or not, and whether I'm getting the data for these data sets that is running in the Spark cluster. As you can see, I've been getting results. I've tested around 4 queries. Yeah, and I found out that storage abstraction and schema on road and business values are these insights for my Hive cluster. And using Apache Spark, I wanted to show whether the EDA graphs that are plotted earlier are convenient or not. As you can see, I've showed two graphs whether in Spark they are executing correctly or not. As you can see, the EDA graphs are executed successfully using Spark Apache clusters. And insights are for the lazy evaluation and key fields confirmed in trend analysis. Lazy evaluation is that for most of the analysis, it tests immediately. And now comes the main objective for the front end part, that is real-time analysis, whether our cluster, Spark cluster is performing incoming transactions in real time or not. I've segregated my whole data into different chunks of 800 rows each, because I wanted to stream the data, because the main objective of Hadoop or Apache Spark is to stream the data without any data loss or any data uh, streaming issues. So instead of uh, streaming issues, I wanted to give a burst of data at a single time for the user. So I have got the data, our data, and I have segregated that into 800 row chunks of each. So we'll be getting around six combos, six streaming chunks of 800 each, and I wanted to check whether each value is streamed perfectly or not in the real time stream. So after all the classifications, I started the stream and checked whether our data is dropped perfectly or not. Our data is perfectly sent into the stream, and we can see whether the data is normally uploaded or whether we have any alerts. So as we can see that amongst the 4,600 rows, we can see that the normal data is 4,000 rows, and negative balance that we flagged earlier were 359, and excessive contacts and repeated shots as well. So based on that, I found out that the risk analysis and campaign analysis and live monitoring is there. And this comes the parallelism, where we can see that uh, serial data and parallel data has been coming along with the catch parallelly. Here we can see that I have shown the results as well for that. How much time is it taking for each and every uh, the aggregation on one partition is for serial, and aggregation for 8 partitions is on parallel data. It is taking around the similar time because we have only 4,500 rows. But if we have any millions and millions of rows, then it would be uh, a significant change in time. So based on our requirement, we would be suggesting to see uh, or opt for either serial parallelism or for either for serial parallelism or for data parallelism. As we can see that here we are getting eight-way parallel road for each and everything. So because each thing should be balanced approximately. That is what I've mentioned here. And this is a little bit of future work if we wanted to perform on my data, to perform all the sanity checks and whether our data is performing or not, whether people will subscribe or not. And yeah, that is my conclusion as well in the data set. And this is my objective and challenges faced when I'm doing my project, and outcome as well. So yeah, this is my project regarding bank marketing of Capstone Project 8. Thank you.